Everyone, I am Lalita Ishwaran. I am going to speak about the topic electrochemistry. This is one of the CSIR topic. CSIR is nothing but Council of Scientific and Industrial Research. So I am going to explain in a very simple manner about the basics of this topic. So let us climb the first step on the ladder to be strong in scientific knowledge to achieve success in this world. So the subtopics that I am going to deal in this video are electrolytic cell, postulates of Arrhenius theory, its advantages and limitations. In order to explain this concept, I am going to speak bilingually. Okay. So for much more clarity of the concepts. The first topic is electrolytic cell. This diagram shows a simple representation of the electrolytic cell in which we have a vessel in which the electrolyte is taken and two electrodes are placed in it. One electrode acts as the anode and another one acts as a cathode, and this is connected to an electric source that is nothing but battery. So when the electrolyte comes in contact with this battery, what happens is there is a dissociation of the electrolyte that takes place. So it breaks up as cations and anions. For example, if we take sodium chloride and place it in this beaker in aqueous form, then it breaks up as Na plus and Cl minus ions. So the anions move towards anode and oxidation takes place, and electrons from anode moves towards cathode, and at cathode the positively charged ions takes up the electrons to form the metal. So reduction takes place at cathode. So redox reaction takes place during the electrolytic reaction in this system. So this arrangement in which the electrical energy is supplied to bring about a redox reaction, which is non-spontaneous, brings about the decomposition of the electrolyte and is called the electrolytic cell. Next one is about the postulates of Arrhenius theory. In order to explain the process of electrolysis, Arrhenius proposed a theory in which it is mentioned that when an electrolyte is dissolved in water, then the first step is dissociation takes place, that is splitting up of the electrolyte. So it gets split up as positively charged ions and negatively charged ions. So if we take sodium chloride, it breaks up as Na plus ions and Cl minus ions. If you take copper sulfate, it breaks up as Cu2 plus ions and SO4 2 minus ions. So in solution, we find that the total number of positive ions and the negative ions are equal. So the solution is electrically neutral. And ions are responsible for the passage of electric current through the electrolyte. So the third one is ionization is a reversible process. So there is always an equilibrium that is maintained between the undissociated molecules and the dissociated molecules. And the degree of ionization increases with dilution. Okay. And the last one is the properties of the electrolytes and the properties of the ions present in it. So chemical reactions takes place between the electrolyte solution between the ions instead of the molecules. So advantages of Arrhenius theory are: this theory explains the phenomenon of electrolysis and Faraday's laws of electrolysis. Secondly, the conductance of the solution increases with dilution. Third one, if we have substances such as copper sulfate or copper nitrate or copper chloride, these are blue in color, and this is because of the Cu2 plus ions which is present. So the properties of the electrolyte is the properties of the ions present in it. And ionization leads to precipitation. That is, when we take, for example, sodium chloride or potassium chloride, when it reacts with silver nitrate, then the ionic form of the chloride reacts with the ionic form of the silver ion, and which results in the formation of AgCl, which gives a curdy white precipitate. Next one is about this theory explains about the enthalpy of neutralization of strong acid with strong base. And the last one is the Arrhenius theory explains about the abnormality in colligative properties, because colligative properties depends on the number of the ions particles present in the solution, and due to ionization the electrolyte molecule splits up into two or more molecules, and therefore the colligative properties of such solutions are more than the non-electrolytes. The last one is the limitations of Arrhenius theory. So Arrhenius theory is applicable only for aqueous solution. It is not applicable for non-aqueous solution, okay, or gaseous solutions. And role of the solvent is responsible for deciding the strength of the electrolyte. For example, if we take hydrochloric acid, it is a strong acid in water medium, but it is a weak acid in benzene. And this theory has not explored about organic solvents, so it deals only with aqueous solutions. And theories based on Arrhenius theory of dissociation have proved to be effective only for weak electrolytes. It is also proved and observed that in the absence of water also, strong electrolyte conduct electricity. So ionic theory, Arrhenius theory says that ionization takes place, but we find that in the solid state also it conducts electricity. So this is contradictory to the Arrhenius theory. So the X-ray analysis of the crystals like sodium chloride shows the existence of ions even in the solid state. So, and ions are also present in the molten state. The theory does not explain why ionization takes place when electrolytes are dissolved in water, and it does not give the explanation about what is the required energy for ionization. Okay, and here this theory does not distinguish about the strong electrolyte and weak electrolyte. So this is all about the concept electrolytic cell and the process of electrolysis, which is explained by Arrhenius theory. So I have given a very detailed explanation about the subtopic in the description box. One can refer and make a note of it. I hope this video was very useful. So clarity in understanding the concept will lead us to confidence in solving the MCQs in any of the competitive exams. So I hope students will acquire knowledge from this video and will be able to solve the MCQs in the competitive exam. Thank you.